Hey, so I wanted to go over the solutions to the first of the stoichiometry practice problems. Again, stoichiometry is something that the more you do it, the more you start to see the pattern of how it works. So starting with the first reaction here, there's a couple things that always help when you're doing these reactions. First of all, if you have a reaction, make sure you go ahead and balance it. All right, so for the first problem, I've gone ahead and balanced it. Notice I've done these in different colors. I've done the different colors just so that you can, when we're doing the relationships, you can tell the what stands for what, because it will, for example, anything having to do with this particular chemical right here, I've represented in red. All right, anything having to do with this particular chemical, I've represented in blue. All right, we've gone ahead and balanced this. And another thing that helps out is if you go ahead and you write out the formula weights or the molar masses underneath each chemical. All right. The thing about all of these relationships is you might need them in a particular to answer a particular question, but you might not. All right. But it helps, especially when you're getting used to this, to have everything written down, and then if you use it, it's there. All right, if you don't use it, you just don't use it. All right, but for now, we're going to start off just by writing down the relationships so that we can pick the right ones when we need them. All right, so when I say the basic 5 reactions or basic 5 relationships, what that means is to write down the 5 relationships that would have to do with just the reactants. All right, as we get further into stoichiometry, we'll create relationships that will use the ones on the product side of the reaction. But for right now, we're just focusing on the reactant side, okay? And the term that I use is 2 glue 2, all right? You're gonna have 2 relationships that have to do with the reactant on the left. We're gonna have 2 relationships that have to do with the reactant on the right. And we're gonna have 1 relationship that will relate the 2 of these things to each other. All right, it will relate the left reactant to the right reactant. All right, so and I call it glue because it glues them together. All right, so the thing about the 2 relationships that you do is that it's always the same thing. All right, so the first of these is going to be just saying 1 mole is a certain number of, how many particles is that? All right, and again, this relationship is like saying 1 dozen of something is 12 of something. All right, it just tells you how many that word corresponds to. All right, notice I've done the same thing over here. 1 mole of carbon is 6.02 times 10 to the 23rd. Atoms of carbon. All right, that is the definition of what a mole is. It's just 6.02 times 10 to the 23rd of anything. All right, the other relationship that is part of the 2 is how much that many units would weigh. All right, so let's say that you had 6.02 times 10 to the 23rd formula units of SnO2. Its mass would be 150.71 grams. All right, and where do we get that number right there? That is simply the molar mass. All right, if you took the atomic mass of 110, all right, plus 2 oxygen atoms, it would add up to 150.71. All right, so you're definitely going to want to have your periodic table close by when you're doing these. Notice that for carbon, we say that 1 mole is 12.01 because the formula there is just a single carbon atom, and that's what its mass would be. All right, so we have these 2 relationships. All right, and then the last thing that we need is the what I call the glue relationship, and all that is a mole to mole relationship. All right, and so just going through this progression, what this balanced reaction says is that for every 1 of these, we need 2 of these, all right? Or 1 of these would react with 2 of these, all right? If that's true, then 1 dozen of these would react with 2 dozen of these, all right? And you can put any word in there that stands for a set amount. And so you're just taking that one step farther. 1 mole of these would react with 2 moles of these, all right? So that's how we get this particular relationship right there, all right? When you're doing this in practice, just take the number right there, put it in front of mole, all right? Take the number right here, put it in front of mole, all right? And that's your relationship, all right? So just as an example of other things that we could do, all right? These are some things that you could do, but we don't happen to need to do this for these problems that we're doing, all right? Could I do 2 relationships for this particular chemical? All right, well, take a look up here. You can always, anytime you've got a chemical in a balanced reaction, or anytime you have any chemical, even if it's not in a balanced reaction, set up, just say 1 mole of something, 1 mole of whatever that chemical is. One of the relationship is just the molar mass, number of grams of that. The other one is 6.02 times 10 to the 23rd, number of whatever that is. We say atoms here because this is a single atom right there, all right? We could do the same thing for carbon monoxide, all right? I just haven't written those here. The glue relationships, all right? Notice we've got a balanced reaction right here, all right? I could relate this particular chemical to this particular chemical just by saying for every one of these, I should be able to make one of these, all right? So and you could express it like that. Notice this number right here, 2 moles of carbon. I could relate that to this thing over here, 2 moles of carbon dioxide or carbon monoxide. All right, I could relate this thing right over here to this thing right over here. And notice all I've done is pulled the numbers out of the balanced equation. All right, we are not going to need these particular relationships for the first problems that we're going to do, but just realize you can do these same type of relationships for any of the chemicals that are in the reaction. All right, so let's go back and focus on just the, again, the first questions that we're going to deal with are only going to deal with things on the reactant side. We're not going to worry about this right here for right now. All right, so how many grams of carbon would be required to react with 3.4 grams of tin oxide? All right, so this is just like a widgets and gizmos problem. All right, you're going to start the crossbar with what the question provides you. All right, so this is the information provided in the reaction, or sorry, in the question. Okay, so notice that whenever you're either doing these relationships or putting the things in the crossbar, there's always 3 elements to what you're putting in there. The first thing is a number. All right, there's always a number of something that you're putting in. All right, the second thing is a unit. You've got grams here, it could be moles, but there's a unit there. And then the third thing is an of what. All right, and so just think about like if you're doing a recipe and it's giving you the ingredients, it would say something like 2 teaspoons of oil, 1 gallon of milk, all right, 3 cups of flour. There's always 3 elements of that. There's a number, a unit, and an of what, all right? And if you don't have all 3 of those, you're going to make mistakes with this, all right? So, so what we want to do, so when you're analyzing this problem, notice that we're starting with something that is of tin oxide, but we're eventually getting to something having to do with carbon, all right, which represented that in blue, all right? What that means is that we're going to have to use this relationship somewhere in the crossbar. It's the only way, it's the only thing that lets us get from something having to do with this red thing, which is what we're starting with, to this blue thing, which is what we have in the end, all right? So always ask yourself, try to get to this as fast as you can. if you can get there in one step, do it in one step. All right. So let's see. Can we put this in the crossbar? All right. Not yet, because we know that this crossbar needs to have grams of SnO2 down here. All right, we need that diagonal relationship. Okay, so where do we have grams of SnO2? All right, that's going to be right here. All right, so I'm going to use this relationship right here. And the question is, do I put it in just like it's drawn right here, or do I need to flip it upside down so that it gets the units in the right place? All right, this has already got it in the right place. So I'm going to put 150.71 here. And then I'm going to put 1 mole. Okay, and all I'm doing there is taking the number from the top and putting it up there. All right, so again, after you put in something, ask yourself, can I use this yet? All right, so now I can, and the reason that I can is that I know that I need moles of tin oxide down here, and this relationship has moles of tin oxide. So the thing is, in order to use this, all I'm going to do is take that relationship and flip it upside down. All right, and that's going to put 1 mole SnO2 down here, and we're going to switch pen color. 2 moles of carbon. All right, so this is the point where I say, like, you're at the 50-yard line. You've gotten halfway there. You've gotten to something that related to tin oxide to something that relates to carbon. So now focus on where you want to get to. We want to get to grams of carbon. All right, so do we have grams of carbon right here in the upper right? Not yet. So what we need to do, we're just going to continue the crossbar. All right, and we want to search where do we have grams of carbon? We have it right here. All right, so can we use this relationship? Yeah, because I know that we need moles of carbon right down here. All right, 1 mole of carbon. And all I have to do is take this thing and turn it upside down. All right, and that puts 12.01 grams of carbon up top. All right, so notice you have your crossbar correctly set up. You've got this unit right here, grams of SnO2 matches grams of SnO2. Moles of SnO2 matches moles of SnO2. Moles of carbon matches moles of carbon. The crossbar starts with this information right here, and it ends with grams of carbon, which is what the question asks for. All right, so what you're going to put into your calculator is just 3.4 times 1. Well, actually, you don't have to put the 1. We're actually going to say, just going to say 2, because that's where that comes from, this part right here. All over. Actually, all right, and notice the way I'm writing this, I'm doing the old divide by symbol. When people are putting their numbers into their calculator, this gives you the order that you can do so that it works. All right, put those numbers into your calculator and it should give you the right answer. All right, we'll do the next question in the following video.